Hello, in this video we want to show you our new regulated digitally controlled switch mode power supply. As you would expect from an ordinary power supply, it has an input and output, and because it's digitally controlled it has serial communication port, which allows you to control all the parameters from the PC. First, let's have a look at the power stage. The power stage starts with the standard AC voltage rectifier, followed by the pulse width modulator. The modulator is loaded by the full bridge current source inverter. The full bridge has LC oscillating load, followed by the transformer and high frequency rectifier. The output filter is pure capacitive and has no inductor. Because the current source inverter is known to have potential overvoltage situations, we have an active overvoltage protection circuit. The digital control is implemented using Texas Instruments DSP. The DSP receives the key signals from the power stage and outputs the control signals to the MOSFET drivers. The bridge MOSFETs are operated under zero voltage switching conditions. The digital control ensures the soft switching for any loads and for all input voltage range by adjusting the oscillation frequency around 300 kHz value. The digital control also provides synchronous bridge and pulse width modulator operation. Because the voltage shape of the bridge load is close to sinusoidal, the transformer efficiency is high and the output filter does not require an inductor. As a consequence, there is no overvoltage stress for the output rectifier diodes and the output high-frequency noise level is low. Let's talk about the tools. We have a special tool to communicate with the power supply and control its parameters. The configuration parameters can be viewed as text, can be saved to a file or read from a file. Currently, the power supply has about 70 configuration parameters and monitoring values. We can switch to graphical view and see the same parameters as text boxes, checkboxes and sliders, which is much more convenient in many cases. We can refresh the selected parameter values during the experiment. The values to be updated as selected in the list box. We can filter out the parameters of little interest and get the display more informative. And because it is a digitally controlled power supply, we can change the target output voltage value and see that it does actually change. To get this precise control of the output voltage, a feedback loop is implemented. If you have ever designed feedback loop for traditional analog power supply, you may have used a device called Frequency Response Analyzer. It allows you to get AC frequency response of your power stage, which is essentially a loop gain without correction. And that is the first step before you can reliably close your feedback loop. With the digital control, you get an embedded digital frequency response analyzer for the cost of the DSP. Let's first turn off all the corrections and measure the initial feedback loop AC response. Now let's turn on one of the corrections we have and measure again. Here are the two curves, and we can see that the corrected one has a much better phase response and a better phase marking. And finally, we would like to show you the firmware update process, which is really simple once you have an output file from Code Composer Studio, which is Texas Instruments IDE. You choose the file, press flash button, wait 1 minute, and you are done. This is very convenient both in the development process and during support phase, and this allows you to meet specific customer requirements without any hardware changes, and this is actually one of the very powerful things the digital technology offers to the power supply designers. Thank you for watching. Goodbye.